Who will name Planet X if and when it is discovered? How will cats use the litter box in space? Can a star block an entire galaxy? And in Q&A Plus, what happens if we find proof that there's no life anywhere? All this and more in this question show. It's time for the question show. Your questions, my answers. As always, wherever you are across my channel, if a question pops in your brain, just write it down, gather them up, and I will answer them here. All right, let's get into the questions. Aaron Brinkerhoff, how sure are you that Planet 9 exists? I'm not sure at all. I am a reporter, so two very respected scientists have done the math, looked at the motions of all of the objects in the outer solar system, and it seems that something is perturbing them. Something is pulling them around. And we've seen this before. This is how Uranus was discovered, that its gravitational influence on the outer planets was so great that astronomers were able to calculate where Uranus should be. And then they pointed a telescope in that place and they found it. And it's the same thing. So astronomers have calculated the motions of all of the objects in the outer solar system, and they've found that you can explain their motion, that there is something big out there that is perturbing their orbits. But this thing is very dim and very far away and very hard to find. And so it's going to require luck or a very powerful telescope like Vera Rubin. Dem Pilafian. If James Webb discovers Planet 9, what will be the process for naming the new planet? Will it be contentious? Well, the telescope that's probably going to discover Planet 9 won't be James Webb. It's going to be Vera Rubin. Like nothing else is scanning the sky at that level of depth to be able to turn up an object like Planet 9. It's going to be Vera Rubin. Now, Webb, once it is told of the precise location of Planet 9, will be able to do follow-on observations and we'll learn a tremendous amount. So who will name it is kind of interesting. So generally, when you're naming new objects, like new dwarf planets, the name is approved by the International Astronomical Union. This is the group of astronomers that meet every 4 years, different countries around the world, and they vote on a bunch of stuff. One of the things they voted was to unplanet Pluto. But they are also going to be voting on, on the names of new objects. And they've named a bunch of stars, extrasolar planets. They've named a bunch of dwarf planets. Now, the discoverer usually gets a vote, a pretty big vote. And so when you think about Eris or Haumea or Makemake, the name of that world was proposed by the person who discovered it. And the IAU, like as long as the name is provided, if it's not Planet McPlanet Face, the IAU takes that name suggestion in good faith and considers it. If it's a good name, if it's got appropriate connections to the heritage of the place that it was discovered, then they often will go through with it. Now, Planet 9 would be a different creature, I think, because if it does exist and it is very big, like if it is Neptune-sized, Uranus-sized, even Earth-sized, then it's going to be a very significant addition to the solar system, that we have 8 large planets that dominate their orbits, and now we will have a 9th. And so naming it will be very, very important. And I'm sure you're going to get different groups that are different opinions, and then they're going to vote, and in the end, there will be a name for it. But it comes down to the International Astronomical Union. Stephen Kolins. When does Vera Rubin go live and not just testing? Right. So back in June, we saw the first test images from the Vera Rubin Observatory. And this is, of course, this incredible new observatory that's being built in Chile. It's previously known as the Large Synoptic Survey Telescope. It is doing an all-sky survey of the entire night sky seen from the southern hemisphere about every 3 days, and just taking some of the most detailed, high-resolution images that have ever been taken of the southern hemisphere, but all of it. And so anything new that happens, any new supernova, any asteroids that drift through the field of view, any Planet 9s that are out there, any interstellar objects that are passing through, Vera Rubin will see them. And we saw the first images and saw that, yes, indeed, this thing is real. This is a real telescope. And the reality is living up to the hype that we're seeing. Not only, like I think in 8 hours, they discovered 1,000 asteroids, that this will be contributing 8 times as many asteroids to the asteroid database as all other observatories combined. It is a ludicrous telescope. And its big 10-year operation, which they're calling the Legacy Space survey time of space and time is due to begin later on this year. So we are just a couple of months away from the beginning of that operation. And when they do, it's going to be a really fascinating process because they've got this enormous data feed that they're going to be pulling out of this telescope. And then they're going to be trying to filter through it and identify a bunch of objects that are interesting for astronomers immediately in real time. There's all these data brokers that they've got processing these data. And so the goal is that you can tell the supernova researchers as quickly as possible the supernova has been detected by Vera Rubin, that it will be filtering out the good stuff and getting that word out there. But then all those data will be available in these gigantic databases that anybody who needs to, and it's freely available, right? If you are a skeptic about space and astronomy, learn to query large databases and you will be able to answer any question that you might have about what's out there in the universe. This is all going to be freely available. And so anyone who wants can go back and look back in time and say, well, what was happening in this galaxy on June 26th, 2026. You'll be able to look back in time and see how a galaxy changed with every single snapshot. And you'll get about 1,000 snapshots of every single spot in the sky, more. So it's going to be just an incredible telescope. And, you think we're excited about interstellar objects today. It's just the beginning, that it is expected to find 6 to 12 interstellar objects every single year. And we will get a much better survey of what these things are and what's out there. Eric Rouleau. Why is it important to study what is outside of the galaxy since we will never be able to go, whether it's the CMB or the universe expanding? I mean, why study anything? Because you're curious. That's it. That's the beginning and the end of the question, which is that if I put the answer to the question, where did the universe come from? Right? I wrote it down and I put it into an envelope and I sealed up the envelope and I gave it to you. And I said, inside this envelope is the definitive, correct answer to the question, where did the universe come from? Would you open the envelope and look at the answer? If the answer is yes, then you're curious. You want to know the answer. You want to know where we came from. You want to know why the universe is expanding. What is dark matter? What happened early on in the universe? These are just questions of our curiosity and nothing more and nothing less. Now, we have seen that this idea of basic science, basic research into just the fundamental aspects of nature have over time revolutionized the way human beings exist. That all of our modern technology goes back to this basic question of, I wonder how that works, right? That's it. And we've got electricity and the internet and radio and so much from just that question. And so you don't know in advance which are the important questions and which are the bad questions. And so you just have to interrogate nature in every aspect whenever it feels like you can make progress and learn more about it. And who knows, it might be in the far, far future, some future group of scientists will finally crack the nature of dark matter and suddenly realize that it's in fact an energy source and that it was all around us all along. And all you need to do is just tune your microwave to dark matter and suddenly it powers your entire house. We don't know. So until then, we find the things that we are curious about. And I think back to when I was a kid. I was interested in dinosaurs. I wanted to know more about dinosaurs. I wanted to know more about space. I was interested in archaeology. I had questions. I had too many questions. And maybe that's still my life. I still have too many questions, and I hope you do too. What is life worth if we're not curious about ourselves, about our friends, about our society, about our culture, about our planet, about nature, and about the universe itself? It makes life worth living for me to both be curious and to find out the answers to these questions. So why do we do this? Because we're curious. And there may be no practical reason. We may never go. But you never know, right? Some future advanced civilization is going to realize that we can colonize about 4% of the observable universe, that those are places that we could reach if we traveled at close to the speed of light, and that they will be studying the positions and the locations and the metallicities of all those galaxies. And when they're ready, they'll send their von Neumann probes at 99.999% the speed of light to those nearby galaxies and colonize them. And it would be good to know, what are the hazards? What are out there? So that's why we do it. It's time to shout out our new $5 patrons and above. Mr. Mark, Carl Fisher, OneStepForAnimals.org, Anthony Lester, Noel Helms, Keith Montgomery, Mark Kilmer, Philip W. Davis, Kevin Hansen, and Stovepipe. Join our community at patreon.com/universetoday. Church discography. How could my cats use a cat pan in space? So if you had cats on the International Space Station and you wanted your cats to be able to use the kitty litter, how could they do it? Diapers? Like, kitty litter just depends on gravity holding your material down. And it's like by necessity crumbly material that you can't just glue to a wall so a cat can use it. And then at the same time, the cat's going to try to swim its way over to your kitty litter box and try to hold itself down while it does that. So no, I think if we try to take cats in space, the only solution is going to be little diapers. The cat is always going to have to be wearing a little diaper, or you're going to get cat turds floating around inside your space station. Ayush Agarwal, is it possible that the individual stars that we see from our point of view are blocking the view of entire galaxies? Yeah, that if you've got a bright star, like something like Betelgeuse or something, a very bright star, it is going to be putting out a lot of illumination. And if you think about all the way back to the beginning of the universe, there are going to be galaxies that are going to be directly on the other side of Betelgeuse from our perspective. And so we won't be able to observe them because Betelgeuse is just too bright. And so if you try to look at Betelgeuse, all you're going to get is Betelgeuse, and you're not going to get that galaxy that is perfectly behind it. And this is the problem with the sun, right? That the sun is this incredibly bright thing that's in the sky, and we don't point our telescopes at the sun because the sun is so bright. And so we look away from the sun. And yet there are galaxies and things on the other side of the sun. And so there will be things on the other sides of stars that we won't be able to see just because they're so bright. Now, the stars are moving. So if you wait long enough, then the thing that was behind the star will eventually be visible again. But yeah, there was, and I can't think of anybody has tried to account for that. Generally, astronomers, when they do these like really deep field surveys, they look at places that are empty. They don't want those stars in the way. But, places like the center of the Milky Way, there are so many stars. There's so much gas, so much dust. It's worthless to look there if you're going to try to look beyond the galaxy. They call it the zone of avoidance. There's just so much junk there. I apologize to the people who live at the core of the galaxy for calling your place junk, but you know what I mean. Christopher Kirby, my 4-year-old Faye asks, why isn't there gravity in space? And talking about how astronauts are floating around on the space station. So there is gravity in space. And this is going to kind of blow your kid's mind, but you are experiencing the gravity of every single thing in the entire universe. Anything that is made of stuff makes gravity. That you are experiencing the gravity of the Earth, and that's what keeps you stuck on the surface of the Earth. But you're also experiencing the gravity from the moon, and that's why we have tides, right? The water goes up and the water goes down, and that's because of the influence of the gravity coming from the moon. We actually experience the gravity from the sun, and that's because when you have the tides, a little bit of the tides are caused by the sun. And in fact, you're experiencing the gravity from every single galaxy, every single star, everything in the whole universe. Here's the part that's crazy. When the astronauts are on board the International Space Station, they are a few 100 kilometers up from the surface of the Earth, and they are experiencing almost the same amount of gravity that you're experiencing down here on the surface of the Earth. And yet they are floating around in space. So why is that? Well, it's because they are falling. So think about when you throw a ball. Right? And you throw the ball and the ball goes on this arc, flies up in the air, and then it comes back down and then it hits the ground. And when the ball reaches the top and it starts to come back down, it is falling. And if you were a little astronaut inside the ball, you would feel like you were floating around inside this ball. Well, the reality is that you're falling and you're about to hit the ground. And so imagine you could throw the ball even farther. You could throw the ball over the horizon, And eventually you can throw the ball so hard that it goes all the way around the Earth and lands, say, behind you. Or you throw it, you turn around, and you catch it. And so for most of that entire time that ball was going around the Earth, it was falling. It was feeling no gravity. That's what's happening on the space station. The space station is following an orbit around the Earth so fast that it is falling. And the feeling that the astronauts have on board the space station is not like what it would feel like to be like underwater when you're like swimming around. It feels exactly like when you're falling the whole time, always. And in the beginning, they get very sick. And they're like, and it's really hard for them to handle because it feels like you're on a roller coaster, or it feels like when you jump off a diving board into the water, or it feels like you're, when your dad throws you up in the air and then you fall back down into his arms. That feeling, that's the feeling that the astronauts are having while they're on board the space station. And it just goes on and on and on. And they can do this, right? The space station has been there for more than 25 years. Falling and falling and falling, and it can never hit the ground because it's going so fast sideways that it just keeps going. And so that's why they are experiencing gravity. If the space station stopped, they would feel like, and just hovered there in space, they would feel exactly the same gravity that you feel. It's because they're falling. Laladieladada. Do I experience the gravity of the pillars of creation, and how? You experience the gravity from everything. And the pillars of creation are giant clouds of gas and dust in the Eagle Nebula caused by the enormous radiation pressure of hidden stars, newly forming stars that are blasting away material. That material has many times the mass of the sun, and you are experiencing its gravity because it is within the observable universe for you. Gravity moves at the speed of light. And so if you can see the light of a thing, you are also experiencing the gravity from it. Edward, what are the contingency plans if someone dies on the ISS? They have them. There is a medical book that is written for NASA for the astronauts on board the International Space Station. And if there is a death on the station, then they have body bags on board the station to put someone into a body bag and put them into one of the Soyuz or the Dragon capsules attached to the station. And then they will bring the person down to Earth for a burial. This is covered in their policies and procedures. NASA has thought about this and considered it. Did you know that you can watch the same video with no ads and get a bonus question over on Patreon completely for free? We call it Q&A Plus. And this week's bonus question, what happens if we never find life? And I'll put a link in the show notes. All right, those are all the questions that we had this time. Thank you, everyone who put your questions into the YouTube comments, everybody who joined me for the live show. Now, we are back with our new season of the live show. And so I'm going to go into all the details of sort of how this all works so that you can join live. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Bear Lake Roofing, Brian Bodie, Caradwin, Chuck Hawkins, Commander Baylock, Cy Nelson, Dave Vera Rubin, David Giltonen, David Matz, Evan Pro, Greg Feely, Hudson Moore, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Russell Smith, Michael Purcell, Monzo, Paul Robach, Ren Kaidu, Richard Williams, Sean Sargent, Stephen Fowler Munley, Vlad Shiplin, and Wolfgang Klutz, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So this episode of the Question Show that you are watching, this is edited from the live show that I do every Monday. I do one of these every single week. It's 2 hours long here on the channel. There should be an event here for when the next one is going to be. The show is 2 hours long. And I rotate the start times. And I know that's confusing, but I do 1 week Pacific Standard Time, 5 o'clock, 1 week at 10 a.m. Pacific times, which makes it evening for people in Europe. And then the next week I go back to Pacific time. And then the week after that, I do it late Sunday night so that it is again in the afternoon for people in Asia and Australia. And that way people from around the world get a chance to watch and participate in the live show. We then cut up the live show, the 2 hour live show, into two about 20-minute question shows, and we release those over the course of the week. All of the extra material we call overtime, and we make that all available over on Patreon. But if you want to watch the raw, unfiltered feed, 2 hours, no graphics, just me talking, I'll put a link at the beginning of every week in the question show when I post it over on Patreon. I'll put a link to the full live show. We make it unlisted here on the channel, but you can access it there and just watch the whole thing just a week after we recorded it live. So if you want to come and participate, it's a really good time, and there's a lot of back and forth, and some of the questions you just never see because there's sort of me rambling or ranting or interacting back and forth with the audience, and it doesn't sort of packaged nicely, but you might find it entertaining. So definitely come and check that out. But just get back into the practice of joining us for the live show on Mondays. We get about 500 people joining, which is great. I get tons of questions, more than I can answer, but it gives me a chance to answer some really cool questions. All right. Hope that explained it. I'll put a bunch of links down in the show notes, and we will see all of you next time.